Good day everyone. My name is Nathaniel Raymundo from BSc 4C, and this report is for the requirements for the subject Compre 2, and the topic is about design of one-way slab USD, or the ultimate strength design. So first of all, in determining if the slab is one-way or two-way, we have the rule of thumb, which is the long span over the short span, or the ratio of the long span and the short span should be greater than or equal to 2 in order to satisfy, or in order to say that the slab is a one-way slab. It is a one-way slab. It just means that the long span, let's say this is the long span, and the short span. So the ratio of those two, um, if it is greater than or equal to 2, it is a one-way slab, which means the load is distributed on this beam here and the beam here only. So these two will not be carrying any loads if it is a one-way slab. On the other hand, if the slab, or if it does not satisfy this rule, therefore we can say that it is a two-way slab if the ratio is less than 2. So if it is less than 2, if it is a two-way slab, therefore its tributary area is like this. It just means that all the forces or all the loads right here will be carried by this beam over here, and so on. And this one will be carried in that beam. So according to the NSCP 2015, we have the minimum slab thickness. So in the section 407 one-way slabs, the minimum slab thickness uh, is written in the code. So we have here the simply supported. The minimum H is L over 20. So L over 24 for one end continuous. If the both ends are continuous, we have the minimum H L over 28. And for the cantilever, we have the minimum H of L over 10. So let's take note of this one. So if the Fy is higher than if it's higher than 420 MPa, the expression shall be multiplied by this equation right here, or by this value. So let's have a sample problem. So the figure shows a cross section of a one-way slab. So the figure is right here. So we have compute the minimum thickness of slab S1. For number 2, compute the minimum thickness of slab S2. For number 3, compute the minimum thickness for slab S3. So how do we solve this problem? So first, let's take a look at the structure. So we can see right here that uh, the beam or the slab is on a cantilever. If we would say it's a cantilever, because we can see that the one end is free from any reactions or support. So there are nothing supporting the slab over here. So therefore, it is a cantilever. So in the NSCP, we have the value for the cantilever, the minimum thickness for the cantilever. So therefore we can solve by using that equation. So for the cantilever, we have the L over 10 So in millimeters, so these are all in meters. So we just convert it into millimeters so that we get the final answer in millimeters. So the minimum slab thickness for the cantilever slab should be 150 millimeters. For the next one, we can see here that both ends are continuous. How did I say that? We can see here that the ends over here um, is continuous since it still has a beam or a slab over here. So therefore, we can say that the both ends of this one is continuous or are continuous. So from the NSCP, we have the given value for the both ends continuous, which is, so the minimum thickness is L over 28. So therefore, we will also have a value of 150 millimeters. So the 4.2 converted into millimeters should still be equal to 150 millimeters. So lastly, we can see here in this structure here that only one end is continuous. So therefore, we can say that the minimum thickness of that slab is L over 24. So for the one end continuous, we have 3.6 millimeters over 24 is equal to 150 millimeters. So a little typographic error here. So this is 3,600 millimeters. So therefore, these are the final answers.